The so-called direct approach to solving this problem would involve converting this to something in quadratic form. So if you multiply through by x, you would get x squared minus 2/3 x plus 1 equals 0. Now you can see fairly quickly that this would result in a negative discriminant. You'd have b squared minus 4ac, which would be a negative. You'd have what, 4 over 9 minus 4, right? B squared minus 4ac. So definitely you have complex solutions here. And you could solve this and then try to substitute the complex solutions in here, but you'd be having to elevate them to the 4th power. And that, to me, turned out to be quite messy. In fact, I wasn't even sure I could do it by hand. I mean, theoretically, you know how to do it, but it's just messy, you know. So there's another approach right here, other than the direct approach, which is to use the binomial theorem and just expand this out. Now, I won't go through the entire, but this term 6 right here that you see, this term 6, is actually the same thing as 4 choose 2. And, this is just the binomial theorem coefficient of this middle term, 4 choose 2. It's 4 choose 0, 4 choose 1, 4 choose 2. And then you actually end up with x squared over x squared, if you guys remember the patterns with the exponents. Okay. So 4 choose 2 happens to be 6. 4 times 3 divided by 2 is 6, right? And similarly for the rest of these. So we get this. And then also, if you simplify this, notice that you have 4 common to a couple of the terms here in a symmetrical sort of fashion. So we're motivated to actually figure out the numerical value of x squared plus 1 over x squared in this process. Now again, notice this process, we're never going to know what the values of x are. We're just using algebraic manipulations to get to it. Now this, after a little bit of arithmetic right here, is equal to minus 14 over 9. And y'all right here, just if you wonder where the 4/9 came from, don't forget x plus 1 over x is given to be 2/3. So if you square 2/3, you get the 4/9 that you see right here. Okay? And then the rest of this is just some arithmetic. I won't write down all the steps, but what you end up with here, we have a numerical value for x squared plus 1 over x squared, namely minus 14 over 9. So just cutting to the chase and writing down the answer after all the arithmetic, we're left here with these guys. This is what we're looking for, right? So we'll be left with x to the 4th plus 1 over x squared plus its reciprocal. Okay, now the common denominator turns out to be 81, not surprisingly. And so you end up with, again, it's very easy to see 81 will be the common denominator. So let's write that down. And then what I got, 504, which is, I don't remember where I got that, but 504, that would be, it would involve 6 times 81 though, since we have this constant of 6 times 81. But let's just, 504 plus 16. Oh no, I know where that came from. Minus 486 is what. How I'll work this. And again, you guys can track the arithmetic. I'm pretty sure I got it right though. Okay, so 486. And when you get everything together here, this would be 520 minus this, which is what, 34 over 81. Yeah, 34 over 81. Okay, folks? So that's the answer. And again, we don't have the faintest idea. Well, I guess we could figure it out now if we wanted to, but we don't have any idea of the value of x. This is just manipulation of the givens using the binomial theorem twice, really. Okay, right here, you don't think of the binomial theorem, but it is the binomial theorem. And you get the two here for the same kind of reasons. You have x times 1 over x occurring twice in this expansion. So that would be 1 plus 1, which is 2, right? Okay, so there we go. The answer, let me see if I can remember it, 34 over 81. So this is equal to 34 divided by 81. And y'all let me know, maybe I'm overlooking something, but again, you could take the time to solve this quadratic and you get, I think you get some root of unity. some complex root of unity, and then, but then you have to expand it. I don't think there's an easy way to do that. You just have to. It's just some work. All right, and then you have to do the reciprocal of that in complex variable. So maybe it's easy. Somehow know that what I just did here is easier in some sense because no difficult calculations really occurred. You just have to know the binomial theorem, and then you end up with some relatively easy arithmetic here. Okay, but if you find the solutions to this, and let me know. I'd love to know which way you think is easier. I personally feel like this messy looking way, which is quite organized really, but you wouldn't think you had to go to this much trouble, but it seems to be a lot of work to actually find the complex solutions here. There's two of them, of course, and then substitute them back in here, and both of them will give the same answer. It works out, because of the nature of complex numbers. But it's or just not just numbers. It's going to work out the same. Period. But anyway, that's it. Till next time.